We can also look beyond batteries at other types of energy storage. So we can look at a supercapacitor versus an energy. So in our supercapacitor, we have a very fast life. It's moderate energy for power delivery compared to our battery, which goes a little slower but has a higher energy to it. Okay, and so supercapacitors are built on capacitor technology, and then we get them to deliver power. All right, so we've got different types of things here. Our supercapacity versus like a lithium ion battery. So if you can see, a supercapacitor is going to charge a lot quicker, voltage a little bit less than a lithium ion battery, and it will operate at a different temperature, and it's a lot more expensive to run. Okay, so if you can look at the cost per watt hour, the cost on a supercapacitor is much higher than a lithium ion battery right now. Okay, but it's one thing to think about, because we do need to sometimes figure out, well, what are some other ways that we can power things? Because mining some of the stuff for batteries might not be something we can do forever. We can also look at things like fuel cells. So a fuel cell is a galvanic cell or voltaic cell that will produce our energy by doing a direct conversion of that chemical energy to electricity without having to burn the fuel. All right. So you need a constant flow in order to get the reaction to continue. So here's a diagram of a hydrogen fuel cell. So you can see that it's got channels for hydrogen and oxygen to both come in, because you have to continually supply that fuel there. It reacts. Hydrogen and oxygen, when they react from their chemical components, do produce water, and so then you have to have an outlet channel for the liquid water that is produced during this reaction. Okay. And so you can see here are the half reactions there. So hydrogen and oxygen, when they come together, we end up getting liquid water. When we look at like a combustion reaction versus a hydrogen fuel cell, combustion is very rapid. Flame is present, not very efficient. We get good heat from it. A hydrogen fuel cell, it is slower, and we don't need a flame for it. And so it is more efficiency. I cannot speak. It is more efficient, and it's better for generating electricity than a combustion reaction is. Okay. We can also generate hydrogen. So this is an example of a hydrogen generating device. So we've got a water tank, we've got a methanol fuel tank, we've got something that vaporizes. We do need a heat source for that vaporization, and then we go through some sort of area with catalysis, and then we end up with hydrogen gas and a byproduct of carbon dioxide. Okay, and then we can look at storing hydrogen for something like a vehicle. Okay, and so we would have our hydrogen tank, we would have our fuel cells. We do need that lithium ion battery still to store electricity. And then we have that electric motor that will propel the vehicle. Okay, now to source hydrogen, we could look at fossil fuels, but again, that's going to produce carbon dioxide and carbon monoxide, which we know by now, not very good things to produce. We can also look at electrolysis of water. So when hydrogen and oxygen react, they form water. If we use electrolysis, electrolysis will split water back into its component elements, hydrogen and oxygen. So that is one area where we could potentially get hydrogen gas. Okay. And so this is just a diagram there of what that electrolysis might look like. And so we would bubble out the hydrogen and the oxygen gases, and so we would have our anode and our cathode, and we would form our hydrogen and our oxygen at each electrode. Okay. And then when we look at our hybrid vehicles use both gasoline and battery technology. And we're getting better at the hybrid as well now. We're getting more efficient with the switch between the battery and the fuel. They're starting to come out with some hybrids that you still plug in like you do with an electric vehicle, and so it charges the battery and then it only switches to gas when it absolutely needs to. And so these are a good kind of transitionary period off of solely gas burning vehicles.